Got it? All right, I'll begin with a word of prayer. Heavenly Father, we thank you for this day. I thank you for the weekend just completed. Thank you for a chance to relax and enjoy the snow a little bit. Just pray that you'd help us today to just wrap up our questions about differential equations and just encourage the students if they're struggling, Lord, to double their efforts and persevere, Lord. In your name I pray. Amen. All right, so questions about the homework. What you guys got for me? Number 34, in which section? Okay. So, number 34, in section 9.1, you're given y1 and y2. Solve, what is it, y prime plus py equals to q. Is that right? Or is the notation different? Oh, there's no q, and it's just p. So p of x, here, let me make it really annoying. dy dx plus p of x times y is equal to 0. Now this we could write we could also write this as y prime plus py is equal to 0 if we don't want to write the x dependence so explicitly. And you're asked to show, what are you asked to show? You're supposed to show that what? Oh, and I'm still not saying it right. Their solution to 9.11, what was that? 9.11 is what? Ah, okay, so these don't solve this, they solve what? This q of x, sorry, right? So there's a q over here. So you're supposed to show that the difference, is it y1 minus y2? Yes. So you're supposed to show that y1 minus y2 is solution to y prime plus py equals to 0. By the way, this has a name. What you're doing here is interesting beyond just this problem. This differential equation has this as the corresponding homogeneous equation. So what you're really showing here, I mean, this is an interesting problem because what you're showing is the difference of inhomogeneous solutions is in fact a homogeneous solution. It's not a solution to the differential equation itself, it's a solution to a corresponding differential equation with q being 0. Goodness gracious, if I write much down to anything here, I've solved the problem. So I will just get us started. So we're given to say y1 and y2 solve y prime plus py equals to q means what? y1 prime plus py1 equals to what? No. These solve this equation. What does that mean? Equals q, right? If somebody said q, and I didn't hear you, sorry. And what? Same for y2, right? y2 prime plus py2 is equal to q. That's what it means for y1 and y2 to be solutions. Now what are we trying to show? You guys are pretty good at doing calculations at this point in your life. Some of you. All of you will soon be very good at doing calculations. Let's say that. All right, let's be optimistic. This is not a calculation, right? This is a proof question. You're asked to show a certain claim. So when you're asked a question like this, it's so important to understand what are you given versus what are you trying to show. And also, this thing you're trying to show, like, what does that mean, right? What does it mean to say that y1 minus y2 is a solution to this? That means what? Exactly. If we put it in this differential equation right here, it equals 0. So our next step is what? Let y equals to y1 minus y2, and consider. What are we going to consider? We're going to consider y prime minus py, right? Now, some of you have been incorrectly taught you put equals to 0 here, and then you work down steps and you get 0 equal to 0, and you're like, yay, 0 equals 0. This is nonsense. This is incorrect. This is not a proof. This is not a way we communicate mathematics. Unless we're an engineer who wrote a series of math texts for unsuspecting homeschoolers. I'm sorry. Oh, I shouldn't speak ill of the dead. Oh well. Okay, so y prime minus py equals to, what does it equal to? It doesn't equal to 0. We don't get to say that yet. That's what we're trying to show, right? It equals to what? What's your next step? y1 minus y2 prime minus p times y1 minus y2, right? Then what do? You use properties of calculus to go from step to step to step. So this is what? And so in this kind of thing over here, I would say, since we set y is equal to y1 minus y2, all right? So that's not a very exciting reason. If you didn't write what's in green, I wouldn't really take off points usually. Yep.
What would you have py subtract?
What are we trying to show? No. Yes, but what are we trying to show? We're trying to show that y1 minus y2 is a solution, right? What does that mean? That means when I plug it in to this differential equation right here, it works, right? So what I'm doing is I'm starting with the left-hand side, and I'm trying to get to the right-hand side through a series of calculus steps based on the givens. What's my next step? I don't like to solve homework problems in here, but I think it's worthwhile for me to do it this day. So this is what? Yes? Right, so this is what? This is y1 prime minus y2 prime minus py1 plus py2, right? By what? Linearity of the derivative, right? In other words, the derivative of a difference is the difference of the derivatives, right? That was a rule we learned in Calculus 1 about differentiation, right? The other step is just algebra, right? Distributive property of multiplication. And then what? Then one more step, just regroup things. I've got y1 prime minus py1, right? Minus parentheses y2 prime minus py2. Again, this is just algebra. No. That is deliberate, because I have minus y2 prime. Why did I write it this way and that way? Now what do I know about the things I have? Let me underline them in red. So what I'm trying to get across to you guys is when we try to prove something, we don't write down what we're trying to prove and then just do steps to show 0 equals 0 or 1 equals 1, something like that. If you were taught that in high school, I'm sorry, but it's wrong. Right? You have to make an argument which proceeds from what is given to what you're trying to prove, and every step that you make should be a logical argument on the basis of things that we know. Algebra, calculus, what's given. So this is what? That's 0, and that's 0 because, well, we were given that, right? We were given that those are solutions to the inhomogeneous equation. Oh, I'm sorry. It's not 0. Listen to me. What are these? I'm an idiot. Yeah. Thank you. So that's more exciting. Oh, you're trying to. I'm sorry. I'm not hearing you. I forgot to write a plus here, right? Yeah.
The original purpose was to go in between the other side. Like in the original
Oh.
Py, that was supposed to be.
Oh, man.
That's what that was.
All right, let me fix this. Yeah, you guys. Yeah. I'm sorry, I'm an idiot. Let's see here. Plus, nothing terribly dramatic here. Plus, what we got here? That's a minus now, right? So do what I say, don't do what I do. Let's see here. Still plus. Minus. All right. I hope I have not distracted you from the larger theme here with my stupid arithmetic mistake. No, I'm sorry. I seem to have solved your problem. But yep. 30, which section?
We do things similar in class,
Yeah, I mean, so we have to, what are you given, did it start from rest? It starts from rest, right? So I guess the way I would solve number 37, so you got what? You got dv dt equals to what? 32 minus kV, all right. So you got like mass, you can think about this as like mass being 1 or something. 32 minus, was it kV? So we separate variables. Right? And then I guess what I would do would be to integrate, say, from V naught, right, to, I guess I just integrate both sides, and then, so what's the integral of this? Minus 1 over k dw over w, right? Where w is equal to what? 32 minus kv, right? So dw is minus k dv. So dv is minus 1 over k times dw, right? So you get minus 1 over k. Well, I'll bring the k over the other side. So I get the natural log of the absolute value of w is equal to minus kt plus, let's say, c tilde. In other words, the natural log of the absolute value, well, fine, we get absolute value w is e to the minus kt times e to the c tilde. So what that gives us is 32 minus kv is plus or minus some constant c times e to the minus kt. I mean, where did you get stuck? The starting point, or just where to start, or? So we separate and then we integrate. Now this is I think we can do by basically a u substitution, right? Now to figure out what that constant is, can we figure out what the c is? What's the initial velocity? 0. Okay. So what's that give us?
0 is 1.
Mm-hmm. So yeah, let's see here. T equals to 0. We've got 32 minus what? 0 is equal to plus or minus c times e to the 0. So therefore, plus or minus c is equal to what? Apparently 32. So what's that give us? That gives us 32 minus kv is equal to 32 e to the minus kt And now you can solve for v. And it shouldn't be that hard to show what we're asked. What are we asked to show? Find v of t. I've almost done it. If I write anything more, I've solved that part. I don't want to do that. But all these velocity problems, all three of the ones that I've assigned you guys, it's the same thing every time. Separate variables, integrate, face the music. I mean the algebra. I mean the algebra in these problems is tough, some of them. Oh, fine. Can you guys, how would I solve for v? Isolate it, right? So I got 32. I can't talk about the next part without doing this. So we got v is equal to what? 32 times 1 minus e to the minus kt divided by k. What are you supposed to show? Part B? Show that v of t cannot exceed 32 over k, and that v of t goes to 32 over k as t goes to infinity. Is that already clear from this formula? How about e to the minus kt? What is that kind of term? It's what? We're given k is positive, aren't we? In the problem, problem statement, I think it says k greater than 0. If k is greater than 0, e to the minus kt does what? It starts out at 1 at time 0, right? And then it drops exponentially to 0. So that is at most 1 for non-negative t. So clearly 1 minus that is always a what? Yeah, it's always a positive quantity. I mean, it has to be, it's 0 at t equal to 0, and then it just dies off. It's asymptotically going to 32 over k. I mean, to answer part B, you just have to analyze this formula. All right? Yeah. For this problem, I think that's fair because the formula is simple enough that I don't think it really requires further calculus. For a more complicated formula, I would expect, application of first derivative, like increasing, decreasing analysis. To give a better answer, you could show something like, you might be able to use one of the deeper theorems in Calculus 1 to analyze it. For example, this one you could show that there's no 0 except t equals to 0, right? And then you could show, if you set this equal to 0, you'll find the only solution is t equal to 0, pretty fast. So the only real 0 to this is t equals to 0. And then all I have to do is show that it's what? It's decreasing, And then I think intuitively it would be clear that you're bounded between the value 1 and 0 as the asymptotic. I don't know. I mean, the question isn't, you could write a better answer or a worse answer, right? I don't want to tell you to write a worse answer. And if I told you what the better answer is, well, then that would defeat the point of homework. So here we are. I don't know.
I just have a question about notation. The line put above the C, where is it left? Little tilde.
Oh, tilde, just because it's no longer C. Oh, because like.
I understand that.
Yeah.
And now, by test, we have to show that there are different C's because it's kind of implied.
Well, it's the custom of most people that when you have, I mean, you could use C in both lines, all right? In as much as it doesn't confuse you. So as long as you're free to use the degenerate C notation, but if you do that, you should beware to not misidentify one C as the other C, which is why I put a C tilde there just to be safe. Yep. Number 30, which one? Oh, here? Section 9.1, number 30? Okay. So this actually kind of is the same question Mackenzie? No, wrong side of Mackenzie. There's two Mackenzies. I knew in the middle was Mackenzie. I couldn't remember if it was Mackenzie or Mackenzie. So I was just guessing. But what was your name? Sabrina. Sabrina's question is actually related to your question here. You're supposed to analyze the solutions to, what is it? It's y prime. I guess we don't need this. You're supposed to analyze solutions to y prime, was it plus ry equals to 0, right? So this question is all about number 31? Number 30, okay. I can't remember anything. Section 9.1, number 30. It's all about analyzing the solutions to this, right? So again, the solutions are so simple that once you find them, I think really a sentence or two, I mean, the question is, first of all, let's solve it. So you solve it, integrating factor technique, what do you get? Y equals to? No? No. Well, it depends on what part we're talking about. But I think generally we get y equals c e to the minus rx, right? Uh-oh. All right, let's go through it. Uh-oh. What's the integrating factor here? Let me just run through it real quick. H equals to r dx, right, which is e to the rx. You multiply this by e to the rx y prime plus r e to the rx y equal to 0, which gives us d dx of e to the rx y equals to 0. Hence, e to the rx y is equal to, say, c. Solve for y, we get y is equal to c e to the minus rx. Bam. That is general. It doesn't matter whether r is positive, negative, or 0. That calculation holds. All right? That calculation is legit. Okay, so then the rest of the questions you're asked are basically, what's the behavior of an exponential function, right? So the question is, what's expected of you? That's Sabrina's question, really. So it's an exponential function, right? We've already studied these. Can I just quote what I learned before in previous courses? The answer is yes, absolutely. For something like an exponential function, in this course, you are free to quote properties of exponential functions. I do hope you understand how to prove those properties from more basic calculus principles. That's also true, but, let's not reinvent the wheel for this problem. For example, part A, you're asked to show at what? Part B, it's at 31, what is it? Wait a minute, are you talking about 30 or 31? 30. Oh, I'm sorry, why do I keep talking about 31? What's wrong with me? Many things, but let's see here. Oh, if it's 0 somewhere, it fixes the constant to be 0, game over, it's identically 0. Part B, if r is less than 0, all non-zero solutions are unbounded. What is, I've already forgot. Was it r less than 0? Yeah. Part B? R is less than 0. What does c e to the y equals c e to the rx look like? It's one of these guys, right? Good grief. I can't graph. It's one of these guys, right? Or it's one of these guys. Either way, as x goes to minus infinity, you have the exponential of a positive infinity, which is infinity. So it blows up either to minus infinity or to infinity as you go to the left. And both of those solutions asymptotically go to 0 as you go to the right. The understanding of part C is just this flipped over. They could have also asked you for part C in this, show the solutions are unbounded for r greater than 0, right? But anyway, yeah. Whoa. Wind it back there. What do you say? If r is
less than 0.
If r is less than 0, uh-huh.
The negatives cancel, it would be c e to the rx.
If r is less than 0, so r might be equal to minus 5. So then y would be equal to c e to the minus 5x. which would be e to the 5x, but it's still equal to e to the minus rx. Minuses don't work that way, symbolically.
Wouldn't that increase as exponential activity?
Oh, yes. I'm sorry. You're absolutely right. This is for... I'm sorry. Yes, I've got it all flipped over. Oh, you know what it is? I was thinking e to the rx. But it's y equals... Yeah, be careful. Don't be like me. Let's see, e to the minus rx. I just get excited here and I forget what I'm talking about. R less than 0, but I appreciate your question because that's helpful. Let's see here. Yeah, that stupid minus is messing with me. So this would either look like that or like that. I should try to be more vague in my answering. Other questions? Mm-hmm. 9.2, number 23. Ah, yes. So 9.2, number 23, it's your lucky day. Someone did the partial fractions in the earlier section, so this is actually equal to, I mean, in other words, let's see, what was the given equation? It was what? Remind me, guys. Was it m dv dt equals to what was it? Minus alpha v minus beta v squared, is that right? So you separate this, you got dv over alpha v plus beta v squared is equal to minus dt over m, right? So you can integrate both sides like this. All right, so the point is this right here, what I have here is actually this. So you can do partial fractions to do that integral. Anybody here successfully do that? Kind of, sort of. So you can check this though. If you make a common denominator of these things, what happens? You get alpha plus beta v up here, minus beta v over there, and then the product of v and alpha plus beta v here gives us, of course, alpha v plus beta v squared, right? Which is what I have over here. And then upstairs, when you add those, the beta v terms cancel, and you got an alpha. Then the alpha over this alpha cancels and gives you the 1 back over here. So you can check that what I have underlined up here is in fact the correct partial fractions decomposition for that function of velocity. Once you have that, then you can integrate like so. And then you can put the alpha on the other side, make it the natural log of the absolute value of the quotient, right? The minus becomes the division by properties of log. Then you exponentiate both sides like so. You pull the plus that exponential, if I have e to the this plus that, that's the same as the product of the exponential times that by properties of exponentials. Then I throw the plus minus of the absolute value into the constant here. And then I solve for solve for v by isolating v. So that's it. The algebra and the solution technique here is very much like what I showed you. I didn't work it out, but I showed you the logistic equation. The calculus that's required to solve the logistic equation is very much like what I'm showing you here. By the way, to relate this constant c to the initial velocity v naught, it's fun to just like take any of these. You can take pretty much any of these equations, put t equals to t naught, and it will allow you to relate. I mean, once I have the constant c, like here, I just plug in t equals 0, then I get a relation between v naught and the c. That's pretty easy to solve. So that in a nutshell is how to solve that problem. Yep.
Section 1.2, 28.
And any questions about this though before I This is a hard problem, right? Took me a lot of writing to get it, if I remember right. Number what, 28? Yes, this is calculus 2. Number 28, I don't think I asked this question. I have not asked this question.
9.2?
Not 9.2, number 28, no. You're talking about review. You're talking about the review questions, right? Yeah, that's actually not 9.2. That's page 467, number 28. That I asked. 9.2, number 28 is way harder. Don't do that one. Unless you're just a chemist and want to solve it. But you can do that in your own time. I will talk to you about something related to the course that I want you to do something like this. So 9.2, number 28 is actually, you're given, 9.2, number 28 is this one. You're given y is equal to like c over 1 plus x squared. It's not 9.2, it's number 28 in the review exercises for the chapter. So yeah, you don't ignore the preamble there, unless perilous to ignore it. I do have an example for that one though. So what I did was just to give you guys an example which is like your homework problem but not the same. I just changed this square to a cube, which is a pretty significant difference. Like I can plot the 1 over 1 plus x squared multiplied by a constant pretty easily. 1 over 1 plus x squared is never 0, right? So it's kind of like this benign little function, 1 over 1 plus x squared is kind of boring. I mean, it's just like this. It's just like whoop, whoop, like that. And so if that's that's y equals 1 over 1 plus x squared. If you multiply that by a positive or negative constant, what happens? You just get one of these guys, or it just. So anyway, the given family for the review exercise you're asked to show is it's a pretty simple family of curves, and you're supposed to find orthogonal trajectories to that, which would be something like, I guess one of them is this. But then other ones are stuff like, so graphically that's what you're trying to do, but you shouldn't try to solve it graphically, right? In fact, you don't even have to draw this picture to understand the problem, is my point. But our goal is, given the family of red and blue curves, to come up with a family of green curves, the so-called orthogonal trajectories, all right? So let's do it for this family of curves, which I will not try to graph because that family is more complicated, actually. Like every graph in here has a vertical asymptote at x equals -1, right? That's actually, I don't know what that looks like. It seems like it'd be kind of nasty. Now, when I talked about orthogonal trajectories before, you might complain that what I showed you in class didn't really give you what you need to work this homework problem, and that may well be the case, because I want you to think. So, read the book, so forth. This one, so the first order of business, right, is to create a differential equation for which this appears as the solution set. The way to do that is just to implicitly differentiate the family of curves. So I differentiate this with respect to x. I get dy dx equals to minus c over 1 plus x cubed quantity squared times 3x squared, right? That's by the chain rule. Now this c is an unwelcome thing. I need to remove that. I just want x's and y's, all right? So just simplifying, this is what the c is. Now what is c? Well, c I can get from over here. I can solve the original family for c. I can trade c for y times 1 plus x cubed. So I just take that and I put it in the place of c over here. Bam. Now I've got a differential equation, right? This one right here, this guy, has as its solution set. Right? This differential equation has that family of curves as its solution set. Now, how do you find orthogonal trajectories to a given family of curves? You take the differential equation corresponding to the family, and then do just negative reciprocal. Right? That will give you a new family of curves whose tangents are perpendicular to the tangents of the given family wherever they intersect. So there you go, -1 over that. Because if I have a line with slope 2, this has slope, -1/2.
So that dy dx is different from that dy dx.
Yes, right. We're asking to find a new family of curves, right? Like over here, I've got, for a rough picture of what you're doing in your homework problem, I'm given this family of blue curves. I'm kind of trying to come up with the family of green curves. So yes, the slopes at a given xy, the slopes will not be equal, though they will be related by minus the reciprocal. Yeah. And so then you do algebra, separate variables, integrate both sides. Notice that the integration, like I asked the earlier section, how do you integrate this? And I got answers like U substitution. No, certainly not. You do not use U substitution to do this integral. This integral is algebra, basic algebra. Right, if I have A plus B over C, that's A over C plus B over C. This is a basic law of algebra. If we don't know this, we certainly can't do calculus. All right? I'm sorry, but, prerequisites in here are not optional. We keep them with us. We use them. And if you don't know the prerequisite material, it will hurt you. Some of you irreparably so, I'm afraid. Given the scores I saw, I mean, if you have a score of less than 30 on this test, I don't know. I mean, you need to either you're not spending time on the course, nothing is sticking, but something definitely needs to change in the way you're studying for the course. I'm not sure what that is for you personally, but I will say this, if you have a score of less than 30 on the test, it's something dramatic has to change, otherwise you will fail this course. It is not an uncertainty for me. I would be shocked if you passed it. Now, I will replace your final exam grade with the, if you do better on the final, I'll replace the first test with that score. But man, that's just wishful thinking. If your score was less than 30, you have so much ground to cover, and we're only a quarter in the course, and the course doesn't slow down for you to catch up. We keep moving, and you got to figure that stuff out. So I don't know. I would be worried if I were you, and if I had a score of less than 30. And that's a lot of you. Well, it's not a lot of you, but there's a significant number of you who have that score, or those kinds of scores. Yes, sir.
What about the quiz?
Oh, quiz, empty threat. Well, we missed our chance for Monday, right? So I'm going to put that. Very good question. Next Monday, I'll give a quiz based on the test, so you have a chance to kind of look at your test and study and so forth. I will post the solution here sometime soon. Anyway, before I digress about the test and all that, is this clear as a method? I mean, I know you were working a different problem. I'm sorry about that. I'm very sorry. That problem is much harder. There's some nasty differential equations which come up in the study of chemistry. Yeah. If I make them homework problems, they're just mean, actually. Like, I think I end up with like dy dx equals like square root of y or something. It's just unpleasant. Or square root of x times square root of y. I don't know. I remember having assigned them in differential equations when I taught differential equations, assigning some of those problems, and they're tough. Sorry about that. Other.
Is that acceptable answer?
Ah.
Or do we have to
Well,
do it like y equals
that depends on the wording of the problem. I mean, if it says to find an explicit solution, this won't do it, but this is an implicit solution. The graph of this equation describes the solution. So, unless I said otherwise, this is a fine. I mean, if it says to find explicit solution, then this is not good. If it just says to find the family of curves which are orthogonal trajectories, we're good to go. So, other questions? Let's look at the test then. If I have a few minutes. Do I have a few minutes? I have a few minutes. Not many minutes, but a few minutes. I have 8 minutes, yeah. That should suffice. Now, I was talking to Dr. Skambordis briefly about this, and he said something about my test being harder. I'm not sure I really believe that, though. You know Skambordis, what integral Skambordis had in his test? I think he had secant cubed in there. That secant cubed is not hard. I think secant cubed is hard. It's just long. No. Eventually, I'll figure out how to plug this thing in. Give me a second. Now, don't misunderstand me, you guys. I want all of you to succeed. I really do. But I also have to be a realist. And, you know...
I don't want to make us succeed by just lowering the bar.
Yeah, well, that's out of the question. Just don't worry about that. Oh, where did I put the solution? Stupid. Uno momento. Come on. Test. How do you get faster at playing the piano? Practice. How do you get faster at math? Yeah. Okay, I think you saw me coming from a mile away there, huh? Come on. Oh, man. Really? It won't let me. All right. The sources button is refusing to button. Is that a word? I don't know. I guess you understood me. It must be a word. Let's try this. You can do it. Woo. All right. Now, so let me just run through these real briefly. First of all, this one. If only I had homework like this. We did have homework like this. Now, some of you, I didn't take too many points off because you drew a triangle and you assumed that the triangle described the ratios. But the rub is that the triangle was a lie for that problem, those of you who tried to use a triangle. But I understand that. Mistake. I made the same mistake myself to start with, but then I checked it against cos squared minus sin squared, and I found out my triangle was wrong. So I understand those of you who did that wrong. That to me still showed evidence of studying, but you just got unlucky. Like I got unlucky the first time, but I checked my answer, and that's why I'm different.
So if you draw a triangle and if you use a triangle and you correctly place everything in,
If you had the right triangle, it would be right, but you guys didn't have the right triangle. Now, yes, sir?
Do you have accurate tests or?
Yeah, I will, but I don't want to distract. And I don't want to call your names out on the video, but I want this to be for the other class to look at if they want. So this one, if only I had talked about some specific thing you could learn how to calculate the inverse derivative of in the review day. Oh, wait a minute, I did talk about that. This very one. Sorry. I specifically wrote this one. Right there. I went through the steps. We spent like a half hour of class doing these. You should not have let me get those points from you. Those are your points. You should have kept them. Problem 3. Come on, guys. This is like one of the first examples you should read in the book or my notes. I may not have worked it in class, but you know what? There's more than just in class. You should read notes. You should study. And more than that, you should try something. And so like here, this is liate, log inverse function, u equals sine inverse. And so this. And this shouldn't have stopped you. That's a u substitution. U substitution. As in you can do it. Sorry. Pun intended. Problem 4. gives me faith in the power of homework. Many of you could do this. This was a homework problem. It's also an easier problem. So, yeah. Those of you who got this wrong, sine of pi is not 1. If only we had done an example like this in class, spent a lot of time about an example like this in class, talked about the general pattern of something like this in class. We did do that, didn't we? I mentioned to you that it's something like this squared plus that squared, it ends up being the division. In this case, 49 plus 1 is 50. You end up with a 1/50th. In fact, that is what happens here. Now, my answer is written in a weird way. Don't let that distract you. This simplifies, and many of you had a better answer than I have right here, right now, which was you got like 7, and then this one just is like -1, so that you can simplify this. The arithmetic is not optimal. Problem 6. You have the tools you need to solve this problem. And some of you did. Actually, not too many of you. So, we had area problems. This is an area problem, so you have to solve for y in terms of x, right? And then you face the integral of the square root of a squared minus x squared. Trig substitution was built for this very problem. All right? So you do trig substitution, and you get pi ab. All right. Problem 7. I say by an appropriate trigonometric substitution. I, out of the kindness of my heart, told you to use trigonometric substitution. Actually, that wasn't too kind. One of you used hyperbolic and ignored me, and it's easier that way. That was not on purpose. I just wanted a trig substitution that tested you on whether or not you could do integrals of like secant squared and also secant over tangent squared, and this is the one for that. Typo? What's that? No, that's... So, trigonometric. Oh. These things will happen. So this is a tangent substitution, and this, when you rewrite in terms of sine and cosine, it's, yeah. So these trig integrals really should not stump you. If you have spent the time to work out integrals of powers of sine and cosine and integrals of powers of secant and tangent, this should have been well within, like, if this was that guy picking up golf balls at the golf cart, you should have nailed him like a bunch of times with his stupid little cage. Yep.
Do you get credit if they use hyperbolic instead of trig?
Depends on my mood.
Okay.
I would say not following instructions is a dangerous game. So here, hyperbolic, I did give them significant partial credit because what they did was of similar difficulty to the problem and blah, blah, blah. But I'd rather not admit that. So here I get cosh squared. This is the motivating example I gave you guys for why to do hyperbolic substitutions, this very problem. Someone didn't really complain. Someone said in the last class, hey, but you didn't do a lot of trig substitution with bounds in the homework. Maybe not, but are there trigonometric substitution with bounds in the book that you're supposed to read? Are there trigonometric substitutions in the notes that I asked you to look at? Yeah, there are ones with bounds in there. And, well, I'll shut up about that. Set up, but do not explicitly determine. Why will you guys not listen to that? Why must you ignore this? Every time people do not read this, do not appreciate this. I tried to show you an example of how to set it up in the review section so that these instructions would be preloaded in your brain. And it didn't, well, it sort of worked or didn't work. Yes, sir?
Did you get full credit if you did A plus BX instead of A plus B?
Yeah. The issue, more critical issue, is that you guys like to put CX plus D for this thing, and that's just nonsense. This is for the decomposition for that one. All right, moving on, because I'm out of time. This one was long division followed by partial fractions. It's not that bad. This one, we did something exactly like this in class. 12, you can't solve any way other than the way I set up number 12 for you with number 11. I gave you what you need to do that. If you had studied these, that shouldn't have been mysterious. That's a low-hanging fruit. Problem 13 is an easier version of one of your homework problems. Problem 14 is boring. Problem 15 is like wire stress substitution without the work. If you'd studied it and memorized the formula, I was giving you credit for it, right? Problem 16. Oh, you're not gonna like this when you see it. If you take the cosh of the natural log of the cosine, it's the e to the natural log of the cosine, e to the minus the natural log of the cosine. Properties of logs and exponentials, that's 1 over cosine. So this is in fact the integral of cosine plus secant. Sometimes I ask you guys to integrate cosine squared plus sine squared just to see what you'll do. Problem 17 was nefarious, I'll admit it. And I gave 2 different versions of it in the different sections, so I'll let you look at that. Anyway, let me give you back your test. We're out of time. You can cut it off so I won't name names.